This is to show you how to do a paired t-test. We would do a paired t-test when we have a reason to believe that our data values between our two data sets are going to be more similar than within our data set. As an example, what I'm looking at here is I have the carbon dioxide generation rate in two different samples. And my two different samples came from the same original data set. So in this case, what I'm looking at is water and the amount of carbon dioxide being generated. So we might have collected water from 8 different ponds. We put the water in 2 different jars, so each pond gets split and put into 2 different jars. And then we measure the carbon dioxide generation when there's light, and in this case, the aluminum foil wrapped one when it's dark. So our pond water is the same between these, but we're testing 8 different ponds. So we might suspect that each pond, labeled as sample here, would be very similar, but between ponds we might have a great difference. So that's when we would use a paired t-test. So each one of our samples is a single pond, but under 2 different treatments. In order to do our paired t-test, what we're going to do is we've got our data set up into 2 categories. Each of our values is the same, so the CO2 generation rate is the same set of data for both columns. We're going to go up to Data, go to Data Analysis, and from Data Analysis we're going to select t-test paired two-sample for means. My variable 1 range, I'm going to select the values for day. My variable 2 range, I'm going to select the data set for night. We're going to set our hypothesized mean difference for 0 because we're trying to show that they are different, so we have to look and say, are they the same? So 0. Now, I have selected as part of each of my data sets the column label, so I make sure that the label box is checked. Alpha set at 0.05, and then I have to select my output range. So my output range, I'm going to put my output right there, and I hit OK. And this has done all of the calculations for me. Always check to make sure that you have the right number of observations. So I had 8 ponds worth of data, so I've got 8 observations. And then we can look at the important parts of this. So I have my degrees of freedom as 7 for a paired t-test. It is the number of pairs minus 1. I have my test statistic, my value of t. We have to make sure to report both the degrees of freedom and the test statistic. And then we've got a couple of things listed down here that are values generated by our t-test. The one that we are interested in is my p two-tailed. In this case, my value for my p two-tailed is 0.043. In our studies, we need to have a p-value less than 0.05 to be able to say that our two are different, and this then gives us a significantly different result between our day and our night values. The other thing you would definitely want to report is that the day value for carbon dioxide generation is larger than the night value, not just say they're different. Now, why do we use a paired t-test here? If I go back and do my data analysis again, but use a normal t-test, assuming equal variance, if I go through and do this, I've got my values still the same. If I put my output down here and run this test, what you will see is that I get the same mean values as I have up here for my paired t-test, but you'll notice my t statistic is very different, and my p-value is non-significant. So how we do our test is extremely important. We use the paired t-test when there is a reason to suspect that our values are paired like this. A two-sample t-test, assuming equal variance, does not analyze our data correctly.